Imagine standing just a few feet away from a handgun as the trigger breaks. In less than the blink of an eye, a bullet explodes forward at speeds that can exceed 1,200 feet per second. Now think about this. A vest only a few millimeters thick can stop that impact and save a human life. Most people see a bulletproof vest as a simple piece of equipment. But what you're about to discover is one of the most extraordinary manufacturing stories on Earth. Imagine standing just a few feet away from a handgun as the trigger breaks. In less than the blink of an eye, a bullet explodes forward at speeds that can exceed 1,200 feet per second. Now think about this. A vest only a few millimeters thick can stop that impact and save a human life. Most people see a bulletproof vest as a simple piece of equipment. But what you're about to discover is one of the most extraordinary manufacturing stories on Earth. And this is where it gets truly extraordinary. The journey begins thousands of miles away from the factories where vests are assembled. It starts deep underground, inside chemical plants, inside shipping containers crossing oceans, and inside some of the most advanced textile facilities ever built. By the end of this video, you'll never look at protective armor the same way again. Most people never think about this, but a modern bulletproof vest begins as crude oil and natural gas pulled from the earth. Large portions of the world's aramid fiber supply trace back to petrochemical feedstocks processed in industrial regions of the United States, Europe, China, and South Korea. Before a vest can stop a bullet, its molecules must first survive extreme chemical refinement. The story starts long before anyone weaves a single thread. Inside giant chemical facilities, manufacturers transform petroleum-based compounds into specialty chemicals that eventually become aramid fibers. Purity levels often exceed 99.5% because even tiny contamination can weaken the final product. Massive reactors, some several stories tall, operate around the clock. The air carries a sharp chemical scent, while pumps rumble with a constant mechanical heartbeat. One of the most famous ballistic materials ever created is Kevlar, developed through advanced polymer chemistry. Similar high-performance fibers now come from multiple manufacturers around the world. A single kilogram of premium ballistic-grade aramid fiber can cost many times more than ordinary textile fibers. That's because every molecule must align with incredible precision before it earns the right to protect a life. But here's what nobody tells you. Those fibers may travel thousands of miles before reaching a vest factory. Rolls weighing hundreds of kilograms move by truck, rail, cargo ship, and warehouse network. Every shipment must stay protected from moisture, contamination, and ultraviolet light. A damaged roll could compromise thousands of future vests. The environmental impact stretches across the entire supply chain. Chemical production consumes significant energy. Transportation burns fuel across continents, and manufacturers constantly search for cleaner processes. Engineers now develop recycling systems for ballistic materials that once ended up in landfills. The challenge isn't just making stronger armor, it's making it responsibly. And just when you think the hardest part is over, the raw material enters a factory where millions of perfectly aligned fibers must become something capable of stopping pure kinetic violence. What happens next turns chemistry into armor, and that's where the real engineering begins. The moment ballistic fibers arrive at the factory, the atmosphere changes. Forklifts move giant rolls through spotless production halls where even small contaminants can affect performance. Workers inspect every shipment under bright white lights, checking for moisture damage, tears, and microscopic defects. Before a single vest exists, quality teams begin a process that leaves almost nothing to chance. Imagine standing beside the weaving machines. Thousands of individual fibers cross over and under each other with incredible precision, creating a fabric stronger than steel by weight. The machines operate at hundreds of picks per minute, producing a constant mechanical chatter that echoes through the building. What looks like ordinary fabric will soon become the foundation of life-saving protection. Some manufacturers use woven fabrics, while others create unidirectional sheets. In these systems, fibers run in parallel lines before multiple layers bond together at different angles. Heated rollers operate at temperatures that can reach approximately 120 degrees Celsius to 150 degrees Celsius, or 248 degrees Fahrenheit to 302 degrees Fahrenheit. You can smell the faint scent of heated polymers as pressure transforms loose fibers into stable ballistic panels. Now comes laser-guided cutting. Computer-controlled systems slice through stacks of ballistic material with millimeter accuracy. Powerful vacuum tables hold every layer perfectly flat, while digital patterns maximize material usage. Bright cutting heads race across the fabric, creating the exact shapes needed for front, back, and side protection panels. Most people never think about this, but a single soft armor panel may contain dozens of individual layers. Workers stack these layers in carefully engineered sequences designed to disperse energy during impact. Every layer must align perfectly. A tiny positioning error can affect how force travels through the vest during a ballistic event. For higher threat armor, manufacturers add ceramic strike plates. These plates often begin as powders pressed under enormous force before entering industrial furnaces. Temperatures can exceed 1,600 degrees Celsius, or more than 2,900 degrees Fahrenheit, as ceramic materials fuse into incredibly hard protective structures. The glowing furnaces radiate intense heat that workers can feel even from a safe distance. After cooling, diamond-coated CNC machines shape the ceramic plates to exact specifications. The sound changes completely here. Instead of textile machinery, you hear the sharp grinding tone of precision cutting tools. Water cooling systems continuously flow across the work surface, preventing overheating while preserving dimensional accuracy. What happens next surprised even experienced engineers. The ceramic alone cannot protect the wearer effectively. Manufacturers bond the strike face to energy-absorbing composite backings that capture fragments and distribute force. It is a combination of materials, not a single material, that creates modern armor's remarkable performance. Frame picture image prompt. The soft panels and hard plates finally meet during assembly. Skilled technicians insert protective components into specially designed carriers made from abrasion-resistant fabrics. Industrial sewing machines stitch straps, pocket, and reinforcement zones with extreme precision. The rapid clicking of needles fills the room while completed vests begin taking shape. But the factory still doesn't trust its own work. Before any vest reaches a customer, engineers prepare for a series of tests that will push every component to its limits. And one of those tests involves something no manufacturer ever wants to see fail: a live bullet traveling at full speed. Now the real moment of truth begins. Every year, manufacturers destroy thousands of perfectly good armor panels on purpose. Think about that for a second. Product that took hours to build and thousands of dollars to produce gets sacrificed so engineers can prove that the next vest might save a life. In this industry, failure inside the factory prevents tragedy in the field. The first layer of quality control starts long before bullets enter the picture. High-resolution cameras scan every panel for wrinkles, gaps, contamination, and alignment errors. AI-powered vision systems compare each product against digital reference models in milliseconds. What the human eye might miss, advanced algorithms detect instantly. Laser measurement systems check dimensions with tolerances often measured in fractions of a millimeter. Some production lines inspect hundreds of points across a single armor component. If a panel falls outside specification, the system automatically removes it from production. Precision here isn't a luxury. It's a requirement. Then comes environmental testing. Engineers place armor inside chambers that simulate years of punishment. Extreme heat, freezing cold, humidity, vibration, and constant wear challenge every layer. Some tests last days or even weeks because armor must perform during the worst day of its service life, not just the day it leaves the factory. And this is where it gets truly extraordinary. Ballistic testing facilities fire rounds that carefully measure velocities that match certification standards. High-speed cameras recording tens of thousands of frames per second capture impacts invisible to the naked eye. The crack of the shot echoes to the range, and within milliseconds engineers know whether the armor passed or failed. International standards demand strict performance requirements. Manufacturers test for penetration resistance, backface deformation, multi-hit capability, and material durability. Rejection rates vary by facility, but even small defects can remove a product from service. A vest may survive multiple inspections before earning approval. But here's something machines still struggle to match. Experienced technicians can often spot unusual material behavior before instruments raise an alarm. After years of handling ballistic fabrics, some specialists recognize subtle texture changes with a single touch. Human judgment still protects quality in ways technology cannot fully replace. By this point, every approved vest carries a combined knowledge of chemists, engineers, machine operators, inspectors, and designers. Yet the story doesn't end inside the factory. The scale of this industry reaches far beyond a single production line, and the numbers behind are almost impossible to imagine. Today, the global body armor industry generates billions of dollars in annual revenue and produces millions of protective units each year. Demand comes from military forces, law enforcement agencies, security professionals, and increasingly from civilian markets. What once served only specialized users has become a worldwide industry spanning multiple continents. The United States remains one of the largest producers and consumers of advanced body armor technology. China, Germany, the United Kingdom, and Israel also play major roles in research, manufacturing, and materials development. Together, these nations drive a large share of global innovation in person protection systems. Think about this. If you stack the ballistic fabric used globally in a single year, the material could stretch for astonishing distances. Millions of workers participate directly or indirectly in the supply chain, from chemical processing and transportation to advanced manufacturing and testing. Most people never see this hidden workforce. Did you know that some armor technologies trace their roots to discoveries made by accident during laboratory research? Scientists searching for one breakthrough occasionally uncover something completely different. What began as experimental chemistry eventually changed personal protection forever. Over the last 50 years, body armor has evolved from heavy, restrictive systems into lighter, more effective protection. Engineers reduce weight, improve comfort, and increase ballistic performance at the same time. Few manufacturing industries have advanced so dramatically in such a short period. From petroleum molecules deep inside chemical reactors to fibers woven with microscopic precision, every stage of this journey serves a single purpose. Thousands of people, countless machines, and decades of engineering knowledge come together to create something most of us rarely think about. Yet most people never think about the science hidden inside a bulletproof vest. They see fabric, straps, and protective plates. But now you know the truth. Beneath that simple appearance lies one of the most sophisticated manufacturing achievements of the modern world. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.